All right, good afternoon, everybody. Thanks for coming out. I appreciate that I'm the last thing standing between you and the attendee party. So we'll spend lots of time in code. We'll make it interesting. I've had my coffee. I hope you've had yours. You're here, hopefully, because you want to learn about Entity Framework Core. I'm Rowan. I work as a program manager on the Entity Framework team. Before we get started, I just want to set expectations about what we're going to cover in this session. So it's listed as a level 200 session, which means it's kind of intermediate. I have a whole range of demos. They go from level 100 all the way through to maybe some 300, possibly even 400 content. So hopefully there's something for everybody in here. I also just want to call out this is about Entity Framework Core. So if you're wanting to learn about EF 6.x, this session is not where to do it, but we have lots of sessions and docs and stuff to get you started with EF 6.x. If you have no idea what the difference between EF Core and EF 6 is, you're in the right place because we're going to cover that near the start. So our agenda is pretty simple. We're going to spend about 10 minutes in slides. We're going to talk about what EF Core is and how it relates to EF 6. We're then going to spend the bulk of our time in Visual Studio doing demos. We're then going to talk a little bit about EF Core 1.1, and then we're going to quickly switch back to demos and look at some of the new features. And then we'll wrap up. I'll head you off in some places where you can learn more. I should also point out, we forget Microsoft, we love acronyms. So EF stands for Entity Framework. I had that on the first slide, but just in case you missed it. Entity Framework takes a long time to say, so EF is what I will say during the talk. All right, naming history. We started off a couple of years ago talking about Entity Framework Everywhere, which is the idea of taking a single data access stack and using it everywhere that you write code in .NET. We soon realized that what we were building was very much the next version of Entity Framework, so we ditched that name and we went with Entity Framework 7, which is what we talked about last Ignite. My session at last Ignite was called Entity Framework 7, Data Access Everywhere. We then realized that what we were building wasn't quite the next version of EF because it was different enough, and calling it 7 made it sound like it should be building on 6, and as we're about to learn, that's not the case. So since then, we ditched that term. We called it Entity Framework Core, clarifying that it's a v1.0. We'll talk about why that's important later. You can think of Entity Framework Core as it fits in with ASP.NET Core and .NET Core and all those things, in that it's lightweight, it's new, it's modular, it's cross-platform. Let's just take a second to talk about where EF has come from. So back in 2008, we released the first version of our product called 3.5 Service Pack 1, which makes real sense for a V1. The reason it was called that is because it was part of the .NET framework, and the tooling was in Visual Studio, which was great. It meant it was easy to get. It also wasn't so great because it meant it took like 2 years between updates. After that, for EF4 and EF5, the new stuff that we were building in the runtime we put on NuGet. The core components that we had stayed in the .NET framework, and the tooling was still in Visual Studio. In EF6, we bit the bullet, and runtime was on NuGet, tooling was on Download Center, and every time we shipped Visual Studio, we would chain in whatever the latest version of those two things was. And Entity Framework Core is going to follow that same model. It's out of band, but you also get the latest version whenever you install or upgrade Visual Studio. At the moment, our team is concurrently working on 2 different releases. We're working on a minor release for both Entity Framework 6, will be 6.2, and Entity Framework Core, which will be 1.1. So as you'll see through here, these are kind of 2 trains that are continuing on, and we'll talk more about what's happening in both stacks. So I'm going to talk through a little bit about what our vision is for EF Core, and then I'm going to show you demos that kind of reinforce exactly what we're trying to achieve. So one of the things we talked about was the idea of being able to run Entity Framework anywhere that I write .NET code. You might have seen this slide in some of the other talks talking about .NET Core or ASP.NET Core. This is kind of how we envisage the .NET world these days. We have different versions of the framework, .NET Framework, .NET Core, Xamarin. We have .NET Standard Library, which is this new thing, kind of like a spec for platforms. When we look at EF6, it fits in down the bottom here in runtime components, but it doesn't target this whole world. It is completely dependent upon the full .NET framework, which means EF6 works for like WinForms, WPF, console applications, old school ASP.NET, not ASP.NET Core, things like that. Entity Framework Core is different because it's built with this new world in mind. And so it lights up all of this. It's compiled against .NET Standard, and therefore targets all of these different things. Now, I do just want to point out here, this is where we're headed with the EF Core. It's not quite reality today. So some of the things we might talk about is that UWP uses .NET Core, but Entity Framework Core doesn't work perfectly with UWP yet. There are still quite a few limitations. It's good for like development and prototyping, but it's not great for building a real app with. We're also working through the process of getting EF up and running in Xamarin applications. You can kind of do it now, but there's a bunch of workarounds. but this is where we're headed. As well as new platforms, people don't just target relational databases these days. So whereas EF6 was specific to relational databases, EF Core opens up a whole new world of providers. Now, what we're not doing is building something crazy and magic, which looks great on a stage, and you just write some code and it magically hides what type of database you're targeting. What we're talking about is building EF with a set of capabilities that make sense for almost all databases. Obviously, not everything works everywhere. And then things that are specific to a particular database or a particular class of databases will be pulled in by extensions. So an example, mapping to a table or a column, well, that's probably specific to a relational database. Certainly when we look at things like the cascade delete behavior on a foreign key constraint, that stuff, they're extension methods that come in when you target a relational database. If I think about, say, targeting Azure Table Storage, which is something we've prototyped, then I want to configure row and partition keys. So that would be an extension method that comes in when I install the Azure Table Storage provider. Here are some examples of things we've worked on. One thing I want to highlight is at the moment, we just have relational providers in terms of RTM'd ready-to-go providers. But to make sure that our stack can handle non-relational providers in the future, we've prototyped Azure Table Storage and Redis, and we plan to bring both of those providers through to RTM quality at some point in the near future, but not immediately. Now that's all great, but there's also a whole bunch of new features that people have been asking for in EF6. And we had the problem in EF6 is some of these features were really difficult and very expensive to implement. EF Core, we've been able to build them in from the start. So I'm not going to run through the list, but here are some features that people asked for a lot on EF6 that are just baked in V1 in Entity Framework Core, available today. Something that, with all of the things that have core on the end of them now, like ASP.NET Core and .NET Core, we want things to be lightweight and extensible. So specific to Entity Framework, this means we have a top-level API, which is DB context and DB set and all those things you're used to if you've used Entity Framework before. But we build it over a set of very small modular services, things that do SQL generation, things that generate values for properties. And those services can be reused, or you can even replace them if you want to. We're also building Entity Framework Core to not use as much memory and not use as much CPU, which is a good thing to do with all software, but we've specifically focused on it for two reasons. One, we want to run on mobile platforms, and there's not an abundance of these things there. Also, we live in a world where you pay for what you use in the cloud, and so using less of this means less money for you to pay at the end of the day. And then pay per play kind of goes back to what I was saying before with relational stuff only comes in when you actually target a relational provider. So if I'm targeting Azure Table Storage, I shouldn't even load the assemblies for a relational provider. So whereas in EF6, all that stuff was baked in, and if you installed EF, you didn't just get all the relational stuff, you also got the SQL Server provider by default, and it was very difficult to get rid of. In EF Core, you only load the assemblies and the code for what you're actually going to use. Like I said, it's helpful to understand how EF6 and EF Core compare to each other. So our kind of motto for Entity Framework Core was we want to be mindful of our past. This thing is called Entity Framework. People gave us good feedback on DB Context and DB Set API, and they liked it. So we don't want to just change everything. We want to keep the stuff that people liked. At the same time, we don't want to be constrained. So EF Core is a new code base. We literally did file a new project a couple of years back and started prototyping things. Once you get under the covers, EF Core is completely different from EF6. And that means that not everything that was implemented in EF6 is implemented in EF Core. Some of it is coming. It's just a matter of priorities and orders. And some of the less common features that just made the stack really complicated and very few people used, well, they're never going to be there in EF Core. When we contrast the two, EF6 has been around for 8 years, actually longer than that. It's 8 years since it first RTM'd. There's a lot of database providers. There's literally hundreds of database providers for it. And we're going to keep doing bug fixes and small improvements and taking community contributions to this code base. So EF 6.x is not dead. We're going to keep working on it. But it's not going to see a lot of new innovation. We're not going to be doing big features in it. EF Core, when we think about it, is new. So it's V1, which means it's not 100% stable. It doesn't have all the features in it yet. And it also doesn't have all the database providers. We have about 10 database providers for EF Core at the moment. So all this boils down to, if you're sitting down to write a new application, EF 6.x is a valid choice for you. If you're thinking about using EF Core, take a look at the features that are implemented and make sure it's right for you before you start. Just bear in mind also that it's a less mature code base. It's only been RTM'd for less than a year. So there are limitations in our link provider. Our link provider is the most complicated part of the stack. So if you're going to hit bugs or limitations, that's probably the first place you'll hit them. And if you do decide to take an existing application and move it from EF6 to EF Core, which I'd only recommend doing if there are features or performance improvements that you really want out of EF Core, then just view it as a port, not an upgrade, and that will set your expectations much more realistically. Obviously, this slide is very high level, and it doesn't actually tell you everything you need. So we have detailed guidance. We have lists of features that are implemented in both the stacks. We have detailed guidance on how to do the port and things like that. So docs.efproject.net is the URL to go to, and there's a section specifically dedicated to comparing EF Core and EF6 and helping you make that choice. Go. That's enough slides. Let's write some code in VS. Now I'm going to start with a 101 demo for EF Core. So actually this will be interesting. How many folks in the room have used a version of Entity Framework so far? Okay, the vast majority of you, that's good. How many folks have used EF Core before? Yeah, maybe like 5%. Great, cool. Let's do a 101 demo. If you've used it, this demo is going to be repetitive for you. So check Facebook for the next 2 minutes or something, or just make sure you actually know what's going on. Okay, so when we talk about Entity Framework, and this is true for both EF Core and EF6, we have a model. And the model is a thing that says, these are the classes I'm going to interact with, and this is how they are translated and talk to the database. There's two things that make up the model. The first one is our entity classes. So I'm going to pick on the usual very boring blog and posts model, just because everybody can grok that. We all know what a blog and a post is. So these are entity classes. They have properties with getters and setters, and those properties are going to map to columns in the database. Okay? We also have a relationship between them, blog and post. A blog has a list of posts, and a post has a blog and a blog ID, which acts like the foreign key. The other part of an entity framework model is the context. This represents a session with the database. It lets us query and save data. So the things to note here, it inherits from DB context, which is actually the same as it did in EF6, but you'll notice now that this is DB context from the Microsoft.EntityFramework core namespace, not system.data.entity. We have a DB set for each type in our model. That lets us query and save instances of those types. And here's something that's new. EF6 would do a lot of magic to work out what database to connect to, and that demoed really great on stage, and it was great for like 101 tutorials, but people would tell us it quickly got confusing and in the way. So we're a lot more explicit in EF Core. So I'm going to override the onConfiguring method, and then I have to tell it which provider to use and what connection string. So we're going to say options builder, which is the thing that just got passed in here. We scroll across with our big font. So this thing that got passed in, options builder.use SQL Server, and if I zoom in, you'll see that's an extension method, and that's because I have the SQL Server provider installed. So we'll do use SQL Server. Everyone knows how to write connection strings, right? So I'll just drag this one in. Okay, cool. The scary thing is I actually do know how to write connection strings now, which it took a few years, but. Okay, so now we have a model built. We have entity classes, we have a context, and we've told it what database to connect to. Let's start doing some data access. For demos and for prototyping, we have this handy API called db.database.ensureCreated. And that's going to go and create a database for me with a schema that matches my current model. Now, obviously, this isn't something I'm going to use to deploy a real application. So I might be targeting an existing database, at which point we have tooling to create the model for you based on the database. So you don't have to even come and type code. Just run a command line, and it will spit out all of your entity classes in your context for you. On the other hand, I might actually want to generate my database from my code, but I'm going to want to be able to migrate that in the future. I want to make changes to my classes and then push those to the database as I ship V2 and V3 of my product. And so to do that, I would use something called migration. So we have solutions for both those things. 75-minute session is not the time to dig into those unless we dedicated it to it. So we're just going to use the simple prototyping method for the moment. Now, you can see here I've created an instance of our blog class. We're going to go ahead and add that to the blogs property, which if you remember would be a DB set of blog on our context. Now, doing that doesn't actually flush that to the database. We have to call save changes. I could add multiple entities. I could delete some and update some, and then call save changes would write all that out to the database. And then we can write what's called a link query. So blogs, not of type, let's order by. The name. And we'll or toList on that, pull everything in, and then let's just for each over it and write the data out to the console. Okay, very simple data access application. Let's run it, make sure it works. So what it's doing at the moment is going to take a few seconds because it's going to go see that I don't have a database. So it's going to create a database based on my current model. It's going to run a set of conventions over the entity classes in the context, inserts the blog, and then it does a query for all blogs, which at this point is just that one that I just inserted, so it prints it out to the screen. And if we quickly swap to SQL Management Studio and refresh, we'll see that we have the database there that I told it to connect to. And we can see it's created tables and columns and foreign key constraints and all that stuff for me. Okay. And then just quickly, for the handful of folks in the room that haven't used EF before, there are ways that I can influence the shape of that schema or tell it about the restrictions that are in my existing schema. So for example, I might want to say the maximum length of data that can be stored in the name property, so using a data annotation, is 200 characters. So if I was creating the database, it would create a varchar 200 column, or I might be mapping to an existing database where EF should be aware that it's a varchar 200, not varchar max, which is what it would choose by default. I might also be in the situation where I don't want I should go back. This is known as data annotations. The alternative to data annotations is something called the Fluent API, where I override a method called onModelCreating. And then I can do things like model builder, pull up the configuration for the blog entity, and let's just change the table that it maps to. Maybe I'm one of those people that likes TBL underscore at the start of my table names. I don't know what you're all laughing about. There's no DBAs in the room? Okay, cool. All right, so that's how I can influence the model. So it's not just about conventions. Conventions help me get started, but I can change stuff. Okay. I won't run this again. You kind of get the idea. It would generate a different database if I ran it again. Okay, for everyone that's used EF or EF Core, you can get off Facebook now because we're actually going to swap back and do some different things. One of the things we talked about, our vision for EF Core, was improving performance. Now, I'm going to demo some things. I'm going to show you that in a lot of cases, perf is better. I do just want to caveat this. Now, I didn't go through and just like cherry pick the few scenarios where performance is better. I just wrote some basic scenarios, and they're the ones I'm going to show you today. But I do want to acknowledge that not every scenario in EF Core is faster than it was in EF6. We are still finding things that we need to improve performance. So if you go home and you get excited about trying perf and you hit a scenario and you're like, man, this is slower than EF6, I'm going to give you a link to our GitHub site at the end. Please file the issue with us. Don't just be like, this product sucks. Go and actually file an issue, and we will actually tune the perf to fix your scenario for you. And thankfully, we've had a lot of people telling us about those, and we've been able to push a lot of great perf improvements. All right. Caveat done. Let's go look at some places where it is better. This project, I mentioned that you can reverse engineer a model from a database, so I did that using both EF6 and EF Core. I pointed at AdventureWorks, so I have two fairly large models here, one with EF6 and one with EF Core. And they're almost identical to the extent that the reverse engineer tools are identical between the two of them. This raises an interesting point. You can actually use EF6 and EF Core side by side. Now, obviously, some of the type names overlap, so there's 2 DB context. You typically wouldn't mix that code in the same file. So generally speaking, the two work fine side by side in the same application. The other thing I have here is a very simple little harness. Basically, we give it a piece of code to run for EF6. We give it a piece of code to run for EF Core. It'll run each of these a few times and print out the results and give us a performance comparison. So let's start out simple. We'll do db.customers.toList. So that's the db set property of customer on our model. And I'll just copy and paste. We'll run that same code down here against EF Core. We're doing perf stuff, so let's just swap to release. Most of our time will be spent in EF code, so that shouldn't really make any difference, but we'll do it anyway. Okay, so a simple query like that, we're seeing EF is significantly faster. Okay. Let's write something a little bit more complicated. So here's one I wrote earlier. And we'll just copy that same code, and we'll run it in the EF Core one as well. Okay, so we're doing a filter, an order by, 2 order bys, we're skipping some rows, we're doing a group by, and we're pulling all that back into memory. Let's give that a run. What's interesting here too is we start to see query caching kick in. So both EF6 and EF Core have query caching, which means when they see a particular shape or link query, they don't do the full translation all the way to SQL every time. In much the same way something like SQL Server has query plan caching, we do the same thing in memory with our translation from link. So that's why we see in our first iteration, we drop from like 1 second down to 3/4 of a second for EF6, and from like 1/3 of a second down to, what's that, about 1/7 of a second or something for EF Core. So that's query. Let's just swap. I have SQL Profiler running in the background, so let's compare and contrast the 2 queries that were executed. Okay, so here's the one that EF Core ran. Yeah, it's fairly simple. By the way, I didn't pick this scenario. I actually only noticed this when I was doing a demo at Build this year. I did this same demo, and I happened to look at SQL Profiler. That's the EF Core one. This is the EF6 one, so it's not really surprising that the EF Core one's faster, right? So anyway, we also generate better SQL. Okay, query is interesting. Let's save some data too. So I'm going to pull over some somewhat naive data access code. If you've written code with EF6, you might be thinking, hey, you can do that quicker than that. So we'll come back to that thought. Let's just write the kind of code that I would typically write when I'm first writing data access. So we're going to create 1,000 instances of product category. We're going to add it to the context and call save changes. And there's one thing I need to change down here. So the change I made, we're creating instances of product category. I could reuse the same entity types, but I didn't want to muck around with doing that. I just kind of reverse engineered from both databases. So I have 2 copies of product category in different namespaces. So I changed the namespace. Aside from that, it is worth noticing that so far with everything we've done, I've been running exactly the same code for EF Core and EF6, which is kind of what we were aiming for. Things are quite a bit faster in EF Core. So actually, the primary reason for this is we now batch on save changes. So when I save 1,000 rows in EF6, it's doing 1,000 round trips to the database. Now, this is running against a local DB database sitting on my SSD attached to my laptop. So imagine what a difference this is going to make if I'm talking to a cloud database. If there's any latency in that, it's multiplied by, it's actually not 1,000. So we can't send 1,000 entities in a batch to SQL Server. They're getting broken up into batches of probably about 100. So we're probably doing about 10 round trips with the EF Core one. So add in the latency times by 100, and you start to see like 99% improvement if I'm talking to an SQL Azure database. Now, this is naive code for EF6. There's stuff I can do to make this faster. So let's do that. So we're going to create an array of product categories. And then instead of going ahead and adding them straight to the context, we're just going to stash them in the array while we're looping through here. And then at the end, once we have them all, we're going to say product categories, add range instead, and add them all in. Okay, adding range is quicker than adding them singly in EF6. And then the other thing I can do, because I happen to know that I don't need EF6 to go and scan for changes to all my entities here, is I can also get in and switch off automatic change detection. And now this code is about as efficient as I can get it with EF6. Now, I could go and make the same changes in EF Core, but let's just run it, see what happens. So as we'd expect, the difference isn't quite as huge, but there's still a significant difference between the two of them. So I'm getting much faster perf, and my code is much simpler. Like, it's easier to understand what I had for EF Core. The reason we can do that is we just made fundamental architecture changes. So change detection is a process where we scan your entities and look for changes that you've made to the properties since we last knew about them. We've just reduced the number of times we need to do that by architecting the stack a little bit differently in EF Core. So this is where starting over again gave us a chance to make some big improvements. All right. Next demo. Let's talk about the model building pipeline. So this is the process where I have my entity classes, and then I might have attributes and Fluent API and things like that. And I mush all that stuff together, and I come up with a model that tells me what my entity classes look like and how I get and set values and how I write those to the database, et cetera. Let's compare and contrast the two quickly. So in EF6, we would take your entity classes and run them through a set of conventions. So we would look for things that might be the primary key. We would work out which properties could be mapped to the database, etc. We would look at your context and see what entities you mention in your DB set properties, and we would pull those in as part of the model. We would then run the code that you have in onModel creating, and we would store it all in configuration objects to say, the user has requested that this property is a primary key. The user has requested that this property has a maximum length of 200. And then we would run a process to combine all of that stuff and make the model. Now, the interesting thing here is in onModel creating, when my code runs, the model hasn't been built yet. So if I want to do something like saying every entity, I want to have a different algorithm to choose the primary key, well, that means we have to build an API in onModel creating to help you do that so that we can store that request in your configuration and then take it into account when we build the model. In EF Core, we took a different approach. So we still put your entity classes through a set of conventions. We still look for DB sets. We then take that and build the model, and we then pass that model into onModel creating, which means at this point, we have a top-level API to help you do common tasks, but you can also get down to the low-level metadata and just start manipulating it yourself if you want to. Let's take a look at how that actually has an impact on the application. So again, I have a blog and posts model here. It's the same one we've been using so far. You'll remember that I went and said, I think it was blog.name had a maximum length of 200, and I did that by putting an annotation on. So if I wanted all string properties to have a maximum length of 200 by default, I could go put annotations on every property, but that would be super annoying. I might also want to change the name of the blog. Remember, we changed it to tbl_blog. Maybe that's what my DBA wants by default. So rather than writing code for every entity that's in my model, let's look at using the actual model and manipulating it. So we're going to go over and for each. So we've got Model Builder, which is our top-level API for common tasks. But from there, I can drop straight down to the model and say get entity types. Entity. And then I can say relational to get access to the relational metadata. Because remember, things like table names don't matter for all providers. So table name equals, so tbl_ was what we said. The entity, we can get the CLR type for it and get the name of the CLR type. OK, so now we've written something that will iterate over and bulk operate on the model. So that's great. I also mentioned the string property one. So let's just say for each property in entity, there's a get properties method there. We probably want to filter that. So we'll strip it down. We'll look at the CLR type, and let's just say we only want the string ones. And I can, we want to set the maximum length on it to 200. OK, so they're pretty simple so far. And we had ways of doing this in EF6, but we only had ways of doing things that we built in API because you couldn't just manipulate the model like this. So one thing we never built a convention API for in EF6 was a way to go through and actually apply conventions to relationships or foreign key constraints if we're targeting a relational database. But now, because we have the whole model, we can easily just go through and say, well, for each foreign key, we'll get all the foreign keys on this entity. And we can say, when we're mapping to a relational database, the name should be, and here's another important thing. We have an algorithm to pick a name. So it does the type name underscore, the target type underscore, the dependent type underscore, the column names. So if I wanted to come up with something like that, I could rewrite that whole algorithm. But because we've already built the model and because we've already applied our conventions, I can actually read the name that's already been calculated back. So name. And maybe all I want to do is make it lowercase because my DBA doesn't like camel case in the database. OK, let's run this. And we'll just prove that all of our conventions got applied. It's just blowing away the database. It's going to recreate it based on the current model. And then if we swap to SQL Management Studio, so we'll see the TBL names are coming through there. We'll see that our text columns are all fixed at 200 by default. And we'll see that our foreign key name has all been lowercased. So I mean, these are tasks you might not actually want to do, but the idea is you have the whole model there. You can really do anything you want to do by just manipulating the object model. Okay, so now we're going to talk about things we did to simplify the stack. One of the most complicated areas in EF6 was the metadata API. The API where I can look at what my classes are and how EF thinks they map to my database. Did anybody in the room ever have to drop down to this in EF6? Anybody? No? Okay, a few hands go up. You probably know what I'm talking about. It was pretty ugly. To demonstrate how ugly it is, I'm actually going to compare the two, and we'll show what it looks like in EF Core. So again, this is a project where I have both an EF6 and an EF Core model side by side. So I have an EF6 version of blogs and posts, and I have an EF Core version of blogs and posts here. And then if I load up my program, I'm basically calling two methods, one to print the EF6 mappings and one to print the EF7 mappings. And what I mean by mappings is I want to say, for each CLR type that's part of my model, which table does it map to? And this is a task that people commonly want to do. I know this because I wrote a blog post on how to do it, and I think it's the second most hit page on my blog. And I'm actually one of the people that hits it, because when we look at the EF6 code, this is the code that it takes to find out what table an entity type maps to. Now, you can imagine if you're sitting down to write this task, you're like, oh, that's pretty ugly code, but it's also pretty complicated code. And you can imagine an object relational mapper probably on occasion wants to work out what table an entity maps to, right? Like every time it saves something or queries something. So this is slow to run, right? So it's not just about the end user code that you're writing, it's about how quick is it for our stack to do these things. It's a little easier in EF Core. So we're going to for each over each item in DB, that being our context. We now have a model property, which is a much better name than metadata workspace for a start. And we can get the entity types. Now what's interesting is this is very similar to the API that I was just using in on-model creating. The difference being that this is read-only, because we've created the model now. So in the other one I was getting entity type, now I get iEntity type, which is an interface which is read-only over it. And we're going to write out some information here. So the first thing we want to do is find out the CLR type, so CLR type.name. And then the second thing we want to do is find out what table it maps to. Now, what's interesting is you can actually map to different tables in different databases. So I want to know what table this maps to when we're targeting SQL Server. So SQL Server, table name. Okay, so what's interesting here, we can configure a relational table name, but then we might say, when I'm targeting Oracle, all my table names should be uppercase. I'm going to configure a different table name for Oracle, and all of those things are stored in my model and accessible. Let's go run this. So one thing you'll notice, the EF6 mappings take a while to come out. And this is actually because I'm not letting it connect to a database. Another interesting side point, EF6, when it builds the model, actually connects to the database to find out some stuff about what version of SQL Server you're targeting, et cetera. And that's quite a slow process. I was not letting it connect, which makes it an even slower process because it comes up with some stuff in memory. EF Core, you noticed, executed very quickly. Okay, so those two very different pieces of code achieve the same thing. Now you might be asking, why is the code so complicated in EF6? And that's largely because EF6 had a whole bunch of very complicated capabilities built in that nobody ever used. And we know people never used it because you couldn't do it using code first. And if you ever wanted to do it, if you were writing an XML file for mapping, you had to get down and hand code the XML. And there was only one person on the EF team who could ever make any of the features work in XML. We had to take our laptops, like, can you make multiple entity sets per type work for me? I cannot get this XML to work. So we know nobody used the features, so we just never put them in EF Core, which makes the code a lot simpler. So we talked about opening EF Core up so that it would run everywhere that you write .NET code. Let's take a look at a couple of examples of that. Now, the main point I want to drive home here is it's not just that you can use EF everywhere, it's your data access code is the same, so your skill set transfers between the different platforms. An important thing to note here too is that not every database provider is available on every platform, okay? So if I'm on a device, I can't connect directly to a MySQL or a SQL Server database, but I can use local SQLite database. If I'm on a full .NET application, then I probably have the whole range of database providers available to me. Similar if I'm on an ASP.NET Core application, then connecting straight to SQL Server or MySQL or anything else that I want to connect to is perfectly reasonable. I have a shared library here, and this data model focuses around the idea of taking notes. So I could be sitting in a session at a conference and I'm taking some notes. I might be in a lecture at university, kind of the digital idea of having a notepad. So we have a context here, the note context. This is all code that we've seen so far. The one thing we have left to do is wire it up to a database. So again, we're going to options builder. This time we're going to use a different method called use SQLite, which is available because I have the SQLite provider for Entity Framework Core installed. Fortunately, everybody does know how to write connection strings in SQLite because they're a lot more concise. So I'm going to tell it to point to a file called notes.db, and that could be sitting in anywhere. It's just kind of a relative path. We'll see that when we target different platforms, where that actually lives will vary depending on the platform. Okay, I should just point out, if we go look at our NuGet packages here, so you'll see I have the SQLite provider installed. So our providers are typically called Microsoft.entityframeworkcore.provider_name. Okay. Now we need to use it. So let's start with a UWP application. So I have one here. We have a page that's designed to write new notes, and we have a to-do in here that once we've created an instance of our note, we want to save it to the database. So this is going to be very basic code that we've already seen. So we create an instance of our context, we add it to the notes.db set, and then we use save changes to flush all those changes out to the database, like so. I've already implemented the existing notes page, which will pull all of the notes from the database using this link query and display them on the screen. And then the last thing I need to do is actually physically create my database. I can't do it now because where my database gets created is going to depend on where I run this application. If it's running on my local laptop, then it's going to go in my local state. If it's running on a device, an Xbox, it's going to go somewhere else. So I'm going to do the easiest thing to create that. On app start, I'm just going to say database.ensure created. Maybe my schema is so simple that I don't really want to care about migrating my database in the future. I don't want to add columns or anything. I'm just going to take notes. I could use migrations and apply migrations from app start to if I wanted to. Okay, we've got all that done. Let's set it as a startup project. Now, this is an important step. I'm going to swap back to debug. I mentioned that our UWP story is not 100% yet, and what happens when you run in release mode is your app gets run through the .NET Native toolchain. EF makes extensive use of generics, and we do a whole bunch of caching and dynamically building generics and stuff, and we don't work super great with the .NET Native toolchain at the moment. So our two teams have actually been working together. When the next release of .NET Native comes out, we're actually going to work a lot better in UWP. What you'll see at the moment, a lot of the time your app will just take a really long time to build, like in the order of minutes to build your app in release mode. Sometimes what you see is that your app will crash because .NET Native won't have generated the code needed for us to be able to execute all of our dynamic generic types and things like that. So I'm just calling that out. While I'm demoing this working on UWP, don't think that you should go and necessarily use this to build a production-ready UWP application yet. Okay, we'll save the note. And we have the note screen where it's pulling the data back from the database. Just to prove that it is actually storing it, let's drop down to disk. I've saved a shortcut to where that app gets deployed to. So you can see in the local state folder for this application, there's the notes database that I told it to create. Okay, so that's a local SQLite database. How many people in the room spend their days working on like cool new technologies like UWP and Xamarin? Who exclusively gets to do that? Cool, yeah, like 3 people. So some of us probably, this might be a little bit more familiar to us from day to day, right? So this is a WinForms application. It's hooked up to the same classes that we wrote down here. And not just a copy of the classes, the actual same classes. And I've done a bit of implementation here. We're going to, just to belabor the point, I could type it very quickly, but let's go copy the same code. So I'll copy this and bring it across. So we're going to use the context to insert the new notes when they come. We'll come back to upload in a second. I have the same link query here, and I'm also creating the database on app start as well. Let's set that as a startup project. I was thinking when I write this demo, you know how everything that's old is kind of cool again these days, like record players and stuff. Surely WinForms is going to be cool again. Something like that. Okay. So the idea being here, I can write the same data access code targeting multiple different application platforms. So we looked at UWP and WinForms. Kind of on the flip side of that, I should be able to use similar data access code to target multiple different databases. So if I'm targeting 2 relational databases, the data access code should be pretty similar because relational databases generally adhere to having the same features and the same syntax and things like that. If I was trying to target 2 different types of relational databases, like a Redis cache and a SQL Server database, I might be able to share my actual entity classes, but a lot of the code that would map them to the databases would be different. The demo I'm going to work on is the formal one, where we're going to take the same entity classes in the same context and map to 2 different relational databases. So far, the data has all been stored in a local SQLite database. So in the case of WinForms, or UWP we saw was in local state, and because I had a relative path, my WinForms application is just storing it alongside the application. So we'll see NotesDB here. That's not a good, durable place to be storing data. So what I want is the ability to go and upload this to a remote database, maybe SQL Server. Now, I mentioned that not all providers work in all places, so I can't just connect directly to a SQL Server from a UWP application. So there's a reason I'm doing this part of the demo on WinForms. We would like to be able to enable that in the future, and we've actually talked with the SQL team about trying to get SQL Client working on UWP, but for the moment, this would only work on certain types of applications, ASP.NET Core and full.NET applications. Let's go back to our context. Now, this code in our shared class library, it has to work on both platforms, UWP and WinForms, so I can't start using the SQL Server provider here, right? Because, like I just said, UWP is not going to support SQL Server. One of the patterns we support to kind of enable these things is we allow you to externally do configuration. So instead of doing configuration inline in onConfiguring, I can instead say, give me a DB context options externally. And I don't really need to do anything with that. All I'm going to do is pass it to the base constructor that takes options. Now, this is an alternative to running onConfiguring. But even when I pass this stuff in externally, it's still going to run onConfiguring, because I might want to do some supplemental configuration. So I'm going to be a little bit defensive in the code here. I could move this out so that everybody's passing in external configuration, including instances that want to talk to SQLite. I don't really want to do that, so I'm just going to say, if any configuration has been done already, then skip it altogether. So I only want to configure it to use SQLite if no other configuration has already been done. And that means I can leave all of my existing code like it is. Now that we've done that, let's go back to our WinForms. And we've got this upload button here. And I'm pulling all of the notes from the database where the column or the property is uploaded is false. This is stuff that I haven't flagged as already uploaded. I've got a connection string here that's coming from my app config, and it is a SQL Server connection string. So I want to take all of those notes. I want to create an instance that connects to a remote database, insert them all, and push them up to the remote SQL Server. Because I'm doing things externally, the first thing I need to do is create a new DB context options builder. This is the exact same API that I was using in onConfiguring. So I have the exact same use SQL Server method here. And then I can get the options from the builder. Now I can create an instance of my note context, but this time I'm going to pass in the options. I'm going to get my NotesDB set and add all of the new notes that need to be uploaded, and then flush those changes to the database. And then once I've done that successfully, I've already got the code here to go through and mark all of the new notes as uploaded, and then save the uploaded flag back to my local database. Let's go run this. And we'll upload. It's uploaded one note to the central database, and we can see that if we flick over to LocalDB. Here's my note taker database, and we're going to select a set of rows, and we'll see my new row being inserted here. So what I've been able to do is reuse the vast majority of my data access code, use all the same mappings and everything, and connect to both a SQLite and a SQL Server database using the same EF Core model. So far, we've just been using the top-level API of EF. But we also mentioned that EF has what I used to call the core components of EF. But when you're talking about EF Core, which has core components, it gets super confusing, especially when you start talking about running on .NET Core or not running on .NET Core. So I started calling them low-level components instead, or low-level services. So let's dig under the covers and see what we can do with that. Because in EF6, once I started digging into the internal components, I realized that EF6 was extremely complicated. It wasn't very extensible. And it was kind of built as a big intertwined. I like to think the implementation of EF6 is kind of like a plate of spaghetti, so it's very difficult to untangle things. So what we tried to do in EF Core is build very small services that have a single thing that they do. And not just that they do, you can pull them out and reuse them, or you can pull them out and replace them with your own implementations. So the first thing we're going to do is look at getting hold of one of the services and using it again ourselves. And one of the services we have is called the type mapper. So this is the thing that says, I have a string property, what data type should I use for it in the database? When I have my DB context, we have this method called getInfrastructure. GetInfrastructure is kind of a way to hide something behind one of our types that's a low-level component that you might want to get access to, but we don't necessarily want to expose on the top-level service. One of the things I can get from a DB context is a service provider. Service provider is not an EF component. It's thought of as, it's kind of like a dependency injection container. It's a collection of services that are used by Entity Framework to do a whole bunch of different things. So there's literally like hundreds of little small services registered in this container, and it takes care of wiring them all up and passing them into each other's constructors and things like that. So it's a pool of services that I can go and get some from. So one of the things I mentioned we might want to get is the type mapper. So from the service provider, we can say get service of iRelational type mapper. And this gets me access to the type mapper. Now there's actually a shortcut I can do here. We have another extension method, which is a get service directly on the context, which lets me write code that just looks like this. I just wanted to walk through those two steps, and now I'm showing you the shortcut about how you can get the code. All right, so let's find out which type mapper is in use. So we'll get the CLR name, so the name of the CLR type of the type mapper. And then we also want to find out, like, given a bool property, what's the database type that would be used for that? So we use the find mapping. That takes a type, so we're going to pass in type of bool. And then store type would be the database type we use. And let's also do that for string. Let's run our code. We'll see that we're using the SQL Server type mapper because this context is wired up to use SQL Server. If I was targeting SQLite, it would be the SQLite type mapper. We see that bool maps to bit and string maps to nvarchar max. Now, obviously, not everyone is going to want to reuse this component, but I'm just showing that of all the components in EF, any one you think of, you could pull out and use yourself if you wanted to. So we've got a bit of time left, and what I wanted to do with that was start talking about what's coming up in EF Core 1.1, just a couple of minutes, and then we're going to drill in and demo. And I'm actually going to pick up where we took off with consuming services and look at replacing services in EF Core 1.1. Before we do that, let's just set a little bit of context about exactly what 1.1 is. I'll just skip over this slide. So EF Core 1.1 is scheduled for Q4 of this year, so coming out in the coming months. And it's focused on making it easier for people to adopt EF Core. So there's still some missing features, some big ones that people need. So we're looking at doing as many of those as we can. And then also fixing a lot of bugs. Obviously, V1 products inherently have bugs in them, so we're trying to fix a lot of them. Here's a list of the stuff that's coming in EF Core 1.1. I'm not going to touch on all of it, but quickly to call out a few. So one of the biggest pain points we've heard was about the maturity of our link provider. And so we're working to translate more queries to SQL successfully. Another one where was the one I was going to talk about? Oh, simplified service replacement. That's actually what we're going to demo next. So in EF Core 1, you could take our services and replace them, but it was extremely complicated and you had to take on a lot of managing dependency injection yourself, which is a huge level up from wanting to just customize the type mapper. Some other ones I call out there, like connection resiliency is great when you're connecting to a cloud database, think SQL Azure database, and there's a much higher likelihood of lost connections when we're doing that. And so that's where connection resiliency comes in. We actually include a thing specifically designed for SQL Azure in the box. So it knows about SQL Azure exceptions. It knows which ones to retry. It knows about sensible wait times and things like that, specifically tailored for SQL Azure. And then here's a couple of things I wanted to call out. These aren't actually going to be in 1.1, but they're very common things that people ask for that our team is currently working on. So if you follow our code base on GitHub, you've probably seen some preliminary pull requests for complex and value type support coming in. We're also doing simple type conversions, which is like I have a JSON object that I want to have in memory, but it's stored as a string in the database. I want to be able to translate that thing into a JSON object as it comes out of the database. And then also one of the things, we have the ability to reverse engineer a database from reverse engineer a model from an existing database. But at the moment, that's a command line tool, which works great, but it's not the ideal user experience. So we're actually building a UI over the top of that to go into Visual Studio as well. Okay, so let's dig in and look at replacing a service now. We're going to keep going with the type mapper example. Maybe I want to customize the type mapper a little bit. I have a blog class here, and I've got a string property called metadata, but I've put this attribute on it called XML. And if we go and look at XML, this is an attribute that I have defined. It's just a simple attribute that I can stick in various places. And then I've got this custom SQL Server type mapper, which inherits from SQL Server type mapper. So that's the type that we saw in my previous demo. This is the type that does the type mapping for SQL Server. What we've tried to do with all these components is factor them in a way that it's very easy to extend them. So for example, running a type mapper, I don't want to go and map every type. I only want to map the new types that I'm interested in. So I'm interested in properties that have that CLR attribute on it. So I'm going to say if property dot has the XML attribute on it, and return my XML type mapping. And this is something that I just defined up here. This is a little piece of metadata that says the type name is XML, the CLR type that matches to it is string, and the ADO.NET data type that matches to it is DB type. Clearly, this is a relational component because it's strongly tied to ADO.NET. Okay, and then I've already implemented the inverse where we pass in the type name and we can get the mapping as well. Now we need to register this, because at the moment this is just sitting in my project and EF has no idea that it should be using this instead of the built-in SQL Server type mapper. And this is where an improvement comes in EF6, in EF Core 1.1. In EF Core 1.0, I would have had to go and externally build a service collection and build the service provider from that and add all of the default entity framework services to it and then override one of them. Instead of doing all that, I can now call replace service, and I can say, when you would have wanted iRelational type mapper, instead of using whatever's registered by default, use my custom one instead. I'm saying, don't use that anymore, use mine. So I'm going to run this application. You can see it runs the same code that we did before. Oh, I didn't set it as a startup project, that's why. Okay, so I will just scroll up and show you that we have effectively the same code that we had written in the one where we consumed the type mapper. So we'll be able to see what type mappings this one's doing. And then we drop and we recreate the database based on the current model. So we can see our custom SQL Server type mapper is there. Bool still maps to bit. String by default still maps to nvarchar max, because remember, we only customized it when it has that particular attribute on it. It's going to go ahead and insert a blog. And then if we swap back over to SQL Server, we'll just refresh the database. We'll go look at the blogs table. We can see that we have the metadata is now stored as XML in the database. So again, this might not be your scenario, customizing the type mapper, but what I'm trying to point out is that all of those services that are there, you can get hold of them and customize them and change them. By default, everything we've done so far has been mapping to properties that have a getter and a setter on them. And in 1.0, that was a hard requirement of EF Core. It had to map to get and set things on a property. We want to relax those restrictions even further, but one of the things we've done in 1.1 is to allow you to map to fields. So I'm just going to close all of this down. We'll set field mapping. That's the project we're going to pick on now. And then let's go look at my classes. Again, we're doing the blog and post model, but there's something a little bit more different about this one. URL is a property, but it only has a getter on it. And it's stored in a field. And then I have a method that is used to set the URL. And the reason I have a method is because I'm doing some work here. I'm actually sending off an HTTP request to make sure I get a valid status code come back that's actually a valid URL with something at it. This is the kind of stuff that would generally be frowned upon to put inside a property setter. We expect setters to do something quick. We expect methods to actually go and do some work. What's interesting about this is EF is not going to pick this property up because it doesn't have a getter and a setter. And I actually ran this application as it is before I came up on stage. And so if we look at our database and look at the blogs table, we'll see that in fact it only has ID and name. The URL column is missing because it's not picked up. So let's go back and include it. So I'm in my onModel creating method. I'm going to say model builder. We'll pull up the configuration for blog. And then we'll call property on it because we're going to configure the URL property. Now, at the moment, that's actually all I need to do because that is telling EF, look, I know this property doesn't have a setter on it, but I want you to include it in the model. And then EF has an extra convention that says, if I have a property in the model, then if there's a field with an underscore property name, then that must be the mapping field for that property. Or it might just be the lowercase version. So we have some conventions to try and pick up the field. Now, of course, that might not be what I actually have. Let's change this. We'll call it the URL just to break convention. At this point, EF won't pick it up, and so it's going to complain that it can't map this property because it has no way to set the value. So then I can say it has field, so I can be a little bit more explicit. So now I can tell it that it has a field. Let's just run our application again and prove that this actually works. Now, one thing to point out while it's recreating the database, EF will favor the property where it can use it. So my property, it's going to use the getter to get data from the property. But when it comes time to set the data, so when it queries an instance from the database and goes to set the value onto the object, there is no setter, so it's going to use the field instead. I can actually be explicit about that as well. After doing has field, I can say, let's just do a new line, use property access mode. I'll just zoom in for you here. So I can actually tell it to always use the field, only use the field during construction, but use the property at all other times, or just always use the property. And if I tell EF to always use the property, but my property doesn't have a setter, then EF's going to give me an exception and say, I can't honor the configuration you've asked me to do because you don't have the appropriate getters and setters for me to do that. And indeed now, if we go back to the database and we refresh the columns, we'll see that URL is now there in the database. What if I don't have a property at all? So instead of URL, let's rename this to getURL and make it a method. Maybe I want to do some logic to massage the URL before it comes back, or do some logging or something like that. So now I can't write this code here because URL is not a property that I can map to. There's two things I can do now. I could just do this. And EF is smart enough to know there is no property called that, but there is a field. That's probably what you meant. So I'm going to use the field instead. So it's effectively going to add conceptually add a property to my model. It's not actually a property in my CLI class, but a property in the model called underscore the URL. And then it's going to map that to the field and just always use the field for data access. The problem is that the name of the property is what ends up being the name of the column. And various other conventions use the name of the property. And I don't really want to muck around with taking the underscores out everywhere. So instead of making that change, what I'm going to do is say, conceptually, I want there to be a property that is of type string and called URL. Now, there's no CLR property, which is why I haven't written a lambda here. And it has a field called underscore the URL. Okay, so I'm now telling EF there's conceptually this property, but you should always use the field to access it. That's going to affect the name of the column and various other things. The other thing that it affects, what if I want to order by this property in a query, which is actually the code I had at the top? I can no longer write this because there is no property. Right? And at the moment, EF doesn't know how to translate my getURL method into SQL. So the other option I have, we have this static method, ef.property, and I can say, there is conceptually this property on blog called URL that I want you to order by. Now, EF is smart enough to know that when it sees this method, it should go and see if this property is in fact present on the blog class defined in the metadata, and it should order by it if it's there. So let's run the app again. I guess I could have skipped dropping and creating the database because the database should be exactly the same. Let's go to SQL Profiler, and we'll see that as far as SQL generation goes, we're still interacting directly with the URL column as if it was a property, but when it comes time to create instances of this object or read the value back to save it, we're interacting directly with the field behind the scenes. All right, one other thing that we've added in EF Core 1.1 is some native support for SQL Server memory optimized tables. So what we're trying to do is take features of SQL Server and give first-class APIs to make them easier to opt into and use if you happen to be using EF as your data access stack. I have an application that we're going to explore that with here. The model that I'm using is based around the idea of a sensor. So a sensor being something like a temperature sensor or a humidity sensor, and that's going to be streaming data back to us. And so we're going to have the ID of the sensor and the sequence, the order in which the data is coming back. And it's going to give us the value, and the time, and some status codes and things like that. The other thing that you'll notice here, if we look at the context, one is that I'm hooked up to a SQL 2016 instance running on my machine. And the other thing you'll notice is that this is heavily indexed data. I have a lot of indexes defined in the database here. And then if we scroll back up to the top, the way my program works, it basically spins up. I'm going to close Solution Explorer so we can see a bit more. It's going to spin up 10 threads. And those 10 threads are going to simulate streaming data back from these sensors and saving it to the database. I'll go to what this monitor sensor method does just to show you. So it's going to create 100 sensor read objects. We're then going to start up a transaction and put them in the database and then query for some data back from the database inside that same transaction. And then the other worker thread that I have is this monitor database one. What that's going to do is look at the performance counters in SQL Server and tell us how many requests per second that SQL Server is able to process. Let's run this in its current state. Nothing about memory optimized tables mentioned yet. So we start by dropping and recreating the database. And then in a minute, we're going to spin up those 10 worker threads. And I'm just going to let it party away on the database. The interesting thing to point out here with this demo is it's streaming a lot of data, and it's very intense around the head of the table. It's always inserting to the end of the table, and it's querying the data back from the end of the table. It's using transactions, and it's heavily indexed data. I'm just going to wait. This will ramp up for a couple. After about 5, yeah, we should drop off a little bit and flatten out. OK, so this is with just standard disk-based tables. We're getting somewhere around about 280 to 300 requests a second through. This is exactly the kind of scenario that memory-optimized tables are designed to improve. So let's go back down to our context. And let's make one change. We're going to say, pull up the configuration for sensor read. For SQL Server, anything that's specific to a provider, we always prefix the methods with a for SQL Server, for SQLite. Memory optimized tables is a SQL Server feature. So for SQL Server, we're going to opt into a memory optimized table for sensor read. And then let's go and run again. Now, I do just want to point out that my laptop with 2 physical cores on it is not a great place to demo memory optimized tables. It gets very quickly CPU bound. So memory optimized tables can give you huge perf increases. Some of the demos I've seen are like 10 times in basic scenarios, 100, even much more than 100 times in complicated scenarios. But they kind of depend on having a lot of CPU to work with. So we're going to see some significant input increases here. what do we go? We went from like 280 to 300 up to 520. So, we're getting up towards a double. But at this point, we're bound by the CPU on my machine. So the point is not that memory optimized tables are a great way to increase performance working against a local database on your laptop. The point is it's easy to opt into this feature using Entity Framework, and we're trying to do that, surface more and more provider-specific features to make them easy to use. So a few important resources that I want you guys to be aware of. So if you want to use Entity Framework Core, then docs.efproject.net is the place to go to. It will have all of the getting started tutorials. It will go through all the things that I've showed you with how to create the models and things like that. If you want to get involved in what's happening day to day on the project, then our GitHub project is ASP.NET/Entity Framework. Another interesting point to make here is our docs are open source too. So just put a .docs on the end of that, so ASP.NET/entityframework.docs, and that's the repo for our documentation as well. And then you might want to pick up and play with the demos. You might want to take some of the demos that I did and show them to your colleagues. So I actually have an open source repo with all the demos and the slide deck and a script for how to do all the demos and set up your machine and everything. So you can find that stuff online too on my GitHub, which is the third link down. Now, before you guys all run off, I know, well, actually, first off, we can look at this slide, which has some pretty animations on it. That was fun. All right, cool. Before you all run off, sometimes I think when you fill out session evaluations, it feels like you're clicking some buttons and it goes off into a black hole. We actually, as speakers, we really do pay attention to what comes back in evaluations. I know you don't get that feedback, but especially when you leave comments saying what was good about the session, what would have been more interesting for you guys to see, that stuff actually changes the way that we build sessions when we're thinking about coming to a conference like this. So not just for this session, for every session you go to at the conference, please take some time to let the speaker know what they did well, what you would have liked to see them do differently, and hopefully that means you guys will get better sessions at your next conference. With that, I want to thank you very much for your time. I'm going to stand around right here and answer all your questions that are coming up. Thank you.